Welcome to our channel Euclid Mathematics. I'm Swapnil sir and today I'm here with one of the previous year question from JEE Advanced, which is completely based on root of our equations. So question is from the section second, that means multiple answer correct type question is that. So we have to check each and every option very carefully. So I already uploaded plenty of the videos on my channel based on JEE Advanced and other competitive exam too. So if you wanted to check this video, you may check it into my playlist. So in my today's video, I'm gonna explain to you all one previous year question from JEE Advanced. So let's get started with today's lecture. First of all, I'm gonna explain to you all question and then we'll go for the detailed understanding of solution. Here in our question, we have given alpha and beta be the root. We have alpha and beta be the root of x square minus x minus 1, which is equal to 0. That means alpha and beta two roots are given for a quadratic equation x square minus x minus 1, which is equal to 0. And alpha is strictly greater beta. That means alpha is bigger than beta. Okay. So that means the relation between these two roots are also given. Alpha is bigger than beta. Okay, for all positive integer n. Okay, so any value if we take from the n for all positive integer n, we get the alpha strictly bigger beta. Okay, and an is given alpha raised to n minus beta raised to n upon alpha minus beta, and n greater equal 1. b1 is given 1 and bn is given an minus 1 plus an plus 1 and n greater equal 2. Okay, this condition hold for some certain values. Okay, so bn hold when n is greater equal to, an hold in when n is greater equal 1. Okay, and then we have to figure it out which one of the option is correct. 4 options are given. So first option, it says that we have n running from 1 to infinity. So summation given n running from 1 to infinity, an upon 10 raised to n, which is equal to 10 by 89. Okay, this one is the first option. Second option, it says that bn which is equal to alpha raised to n plus beta raised to n for all n greater equal 1. Okay, so second option, it says that alpha raised to n plus beta raised to n for all n greater equal 1, which is the value for bn. Okay, third option, it says that a1 plus a2 plus a3 plus an, which is equal to an plus 2 minus 1. And fourth option, it says that n is equal to 1 to infinity series bn upon 10 raised to n, which is equal to 8 by 89. Okay, so we have to figure it out which one of the option is correct. Okay, now let's get started with today's solution. I will explain to you all each and every option in detail. In our solution, we have given alpha and beta are the root of a quadratic equation x square minus x minus 1, which is equal to 0. For alpha strictly greater beta, and for all positive integer it is given. Okay, so meaning for that, if alpha and beta are the root of x square minus x minus 1, which is equal to 0, that means alpha and beta, both of these roots satisfy this equation, quadratic equation. That means whenever we put our root in our quadratic equation, our both side will be satisfied. Okay, so for example, let me explain with one simple example that can give us a root and how can that root satisfy our equation. Okay, so for example, if you consider x square minus 5x plus 6, which is equal to 0. So I consider, for example, as a quadratic equation. And if you're going to find the quadratic root for a quadratic equation, you will get the x which is equal to 2 and x which is equal to 3. Both are the roots of our quadratic equation. Okay, similarly here alpha beta given. Okay, instead of finding the root of x square minus x minus 1, I taken one quadratic equation because just I wanted to explain that how roots can satisfy the quadratic equation. Okay, so if I taken x is a 2 and x is a 3 as a root of our quadratic equation, so you may find this root. Okay, you will get the root of this quadratic equation. Okay, so how can we say that x which is equal to 2 which satisfy x square minus 5x plus 6 which is equal to 0? So this is the root. That means whenever you substitute the value for x which is equal to 2 in our quadratic equation, so you will get the both side equal. Okay, so that means substitute x is 2, so 2 square minus 5 multiplied by 2 plus 6 which is equal to 0. Now check it whether right hand side left hand side are equal or not. Okay, so 4 minus 10 plus 6 which is equal to 0. So 4 minus 10, it will be minus 6 plus 6 which is equal to 0. So 0 which is equal to 0. So what I have done here, first of all, the root which I got from the quadratic equation, I substitute this root back to our quadratic equation, and that quadratic equation satisfy left and right hand side. Okay, that means we can say here x which is equal to 2, which is the root of our quadratic equation, and it satisfy our quadratic equation. Okay, so similarly we have here in our example, alpha and beta are the root of a quadratic equation x square minus x minus 1 which is equal to 0. So if alpha beta root of this quadratic equation, so can we write alpha square minus alpha minus 1 which is equal to 0? Yeah, it is possible because alpha is a root of quadratic equation. It is given in our question. Okay, alpha is a root of quadratic equation, so I can write alpha square minus alpha minus 1 which is equal to 0 by using this quadratic equation. Okay, similarly beta is a root of quadratic equation, so do it similar for beta. So beta square minus beta minus 1 which is equal to 0. Now see that by using this quadratic equation, I got the two another quadratic equations by using the root of our quadratic equation, and alpha is strictly greater beta here. Okay, so now let's just understand what we have given in our question. Okay, so an is given n greater equal 1, b1 is given 1, bn is given an minus 1 plus an plus 1, and n greater equal to, okay, and x square minus x minus 1 it is given which is equal to 0. Okay, so our first option, it says that, so, and we have quadratic equation given x square minus x minus 1 which is equal to 0. Okay, so try to expand the term what we have given in our question. So we have to extract the given information from our question, and then we'll move for the solution. Okay, so first of all, I got these two equation, quadratic equation, by using our roots. Now let's find out the root alpha beta for this quadratic equation. Okay, so quadratic equation we have here x square minus x minus 1 which is equal to 0. Okay, this one is a quadratic equation. Now let's find out the root of a quadratic equation. As usual, method cannot applicable here for finding the root of our quadratic equation. So we have to use some special result like a minus b plus minus under root b square minus 4ac upon twice of a. Okay, this one is a standard result which is very much useful to find out the root of a quadratic, any quadratic equation, especially when we have root in the form of a square root or in the form of a complex root. Okay, if sometimes roots coming like a complex number, then it is quite difficult to figure it out root from our quadratic equation. So that time you have to use this result. Okay, so now minus b a c, what is minus b a c? These are the root values from ax square plus bx plus c which is equal to 0. Okay, so I hope that these things you are familiar with all these things. Okay, this is the quadratic general form of quadratic equation. Compare with this one, so you will get the value for a is 1, b is a minus 1, c is a minus 1. Put a b c over here. Okay, so minus b minus b means 1 minus 1 of minus b. Okay, that means this negative getting positive, plus minus square root of b square, negative 1 square means 1, minus 4 times a into c, 4 times a into c, c is a negative 1, so it will get positive, upon 2 times a, so 2 times 1. Okay, so these are the just substitution of value into our quadratic equation. What we are doing here, we are finding the roots of our quadratic equation. Why? Because we have to extract what we have given in our question. Okay, so here we can see we got the two root, because plus minus sign it is there now, that's why one root it goes to plus, another root goes to minus. Okay, so first root it goes to plus 1 plus root 5 by 2. Okay, 1 plus root 5 by 2, and another root 1 minus root 5 by 2. Okay, so here we can see I got the two roots of our quadratic equation x square minus x minus 1, which is a 1 plus root 5 by 2 and 1 minus root 5 by 2. Okay, so I got the two roots for our quadratic equation. I got the two equation again. Okay, and it one more condition is given that alpha is greater than beta. Okay, so how can we figure that which one is alpha or which one is beta? Because these two roots are distinct. Okay, so if these two roots are distinct, then how can we figure it out which one is the alpha and which one is the beta? Okay, so by using the condition alpha strictly greater beta, okay, alpha strictly greater beta, so using that condition we will find out the alpha and beta. Okay, now we can see that alpha is bigger here. Okay, when alpha is bigger, when we add some number, then this quantity getting bigger, and when we remove some number from one, this quantity getting smaller. Okay, so if you're going to find the value for 1 plus root 5 by 2, you will get the smaller than 1. This one is smaller than 1. Okay, but here addition, okay, because of the addition this number is bigger. Okay, so we consider alpha as a 1 plus root 5 by 2. Okay, alpha as a 1 plus root 5 by 2 and beta as a 1 minus root 5 by 2. Okay, 1 plus root 5 by 2 and 1 minus root 5 by 2. So I got the value for alpha, I got the value for beta, and I got the two separate quadratic equations. Okay, now for finding the values in an, okay, so we have given an, which is alpha raised to n minus beta raised to n upon alpha minus beta. Now here we can see that we have denominator alpha minus beta, so we have to find the value for alpha minus beta. Okay, not only the value for alpha minus beta, because we have numerator alpha raised to n minus beta raised to n, that maybe we need the help for alpha plus beta, that maybe we need the help for alpha into beta. Okay, so we have to find all these three values here. Okay, alpha minus beta, alpha plus beta into alpha into beta. Okay, now let's find out alpha minus beta. So alpha minus beta. Okay, because alpha is bigger, beta is smaller, their subtraction always coming positive. Okay, so alpha minus beta, for finding the value for alpha minus beta, so 1 plus root 5 by 2 minus beta 1 minus root 5 by 2. Okay, alpha minus beta. Okay, negative, always make the bracket for our numbers. Okay, because negative sign is there, negative sign change everywhere the values, so be careful about sign. So go for subtraction. So 1 by 2, I can expand this as a root 5 by 2. Okay, 1 plus root 5 by 2 can be written as 1 by 2 plus root 5 by 2 minus 1 by 2. So negative multiply under bracket minus 1 by 2 multiply negative under bracket plus root 5 by 2. Okay, so plus 1 by 2 negative 1 by 2 get cancelled, root 5 by 2 plus root 5 by 2. Okay, that means we will get the root 5 plus root 5 divided by 2. That means 2 times root 5 by 2, that means it will only root 5. Okay, so I got the value for alpha minus beta here, root 5. Okay, I hope you all have understood this value, alpha minus beta, just an easy calculations. Okay, now go for the alpha plus beta. Okay, so for a value of alpha plus beta, okay, just go for the addition over here. So 1 by 2 plus root 5 by 2 plus 1 by 2 minus root 5 by 2. Okay, so this one get cancelled, 1 by 2 plus 1 by 2 1. Okay, so I got the alpha plus beta which is equal to 1. Okay, alpha plus beta 1, alpha minus beta root 5. Now alpha multiplied by beta. Okay, so 1 by 2 plus root 5 by 2 multiplied by 1 by 2 minus root 5 by 2. Okay, so multiply these two bracket, 1 alpha multiplied by beta, 1 by 2 into root 5 by 2 multiplied by 1 by 2 minus root 5 by 2. Okay, so it is plus here. Okay, this multiplied by this. Okay, so you have to go for the multiplication of these two brackets. So 1 by 2 multiplied by 1 by 2, which is a 1 by 4. 1 by 2 multiplied by root 5 by 2, which can be written as root 5 by 2 to the 4. Okay, so negative sign it will remain same. Again root 5 by 2 multiplied by 1 by 2, which will we get root 5 1 the root 5 and 4. Okay, plus root 5 by 4, it will be plus. Okay, because this plus sign remain plus sign. Okay, and root 5 by 2 minus root you multiplied by minus of root 5 by 2, so minus of 5 by 4. Okay, so this get cancelled, this get cancelled. Okay, so 1 by 4 minus 5 by 4, that means 1 minus 5 by 4, that means minus 4 by 4, which is equal to minus 1. Okay, so here we can see alpha into beta, I got the alpha multiplied by beta, which is a minus 1. Okay, so I got the three values, alpha minus beta, alpha plus beta, alpha into beta. why I found these values. Okay, you need to see first of all question, what we have our question. So in our question, alpha minus beta is given. Okay, if alpha minus beta is given and our numerator is given as alpha raised to n minus beta raised to n, that means surely we need alpha plus beta. Okay, and if alpha plus beta is needed, then find out alpha into beta also. Might be we'll get the multiplication also further. Okay, so here I found these values. Okay, so here we can see the root I found here by the standard result. So I consider alpha is 1 plus root 5 by 2 and beta is 1 minus root 5 by 2 and as alpha greater beta. Okay, so alpha plus beta here, alpha minus beta here, alpha into beta here. Okay, so if alpha and beta are the root of x square minus x minus 1, so we can write alpha as a root. So alpha square minus alpha minus 1 0, it hold, and beta square minus beta minus 1 0, it hold. Okay, so I already explained at the previous part of my solution. So I hope you all have understood. Okay, these all things are given in our question. Okay, all things are given, so we needed all these things to solve our options. Okay, now let's get start our solution options. We'll go through detailed understanding of each and every option. So our options are look like a little bit like a calculation part. So that calculation part, it is quite confusing, but we can solve it easily. Okay, just go for the easy calculations are this. Okay, so here first option say that an upon 10 raised to n in which is equal to summation which is equal to 10 by 18a. Okay, that means when we add n which is equal to 1 to infinity, n upon 10 raised to n, we will get the 10 upon 89. Okay, now let's figure it out whether the value for n upon 10 raised to n is 10 by 89 or not. Okay, so here n is equal to 1 to infinity. The value for an, we know that is given in question, alpha raised to n minus beta raised to n upon alpha minus beta. Okay, multiplied by 1 upon 10 raised to n. Okay, so this term I written this way. Okay, now so we know that value for alpha minus beta. Okay, earlier we found the value for alpha minus beta, alpha plus beta and alpha into beta. Okay, so alpha minus beta we found here root 5, 10 raised to n as it is, alpha raised to n minus beta raised to n as it is. Okay, okay, 1 by root 5 take it out because summation cannot affect on constant numbers. Okay, so 1 upon root 5 outside, n is equal to 1 to infinity, so alpha raised to n minus beta raised to n upon 10 raised to n. Okay, so take the number separately, that we can go for further calculation. Okay, so 1 by root 5 outside, take summation separate, power separate, so alpha by 10 raised to n is equal to 1 to infinity, beta by 10 raised to n. Okay, so this is the way to expand our summation here. I hope you all have understood. Okay, now here we can see summation running from n to 1 to infinity. Okay, so let me explain with this. So we have summation n running from 1 to infinity, alpha by 10 raised to n. Okay, so put n is equal to 1. Summation means we add their numbers. Okay, summation n running from 1 to infinity. So how can we write alpha by 10 raised to 1 plus summation means addition of every term, each and every term, alpha by 10 square plus alpha by 10 to the power 3 plus so on. Okay, so meaning for this term I written this way. Okay, so 1 by root 5 keep it outside, so don't take it now right now. Okay, because we have to simplify this term here, then we'll multiply 1 by root 5. Okay, so don't take that 1 by root 5 right now. So first of all simplify this one. So n running from 1 to infinity, alpha by 10 raised to n, I expanded this way. Similarly you can expand the further term also. Okay, so minus, so beta by 10 raised to 1 plus beta by 10 raised to 2 plus so on. So n means infinite term are there. Okay, so we cannot find the infinite term. At the infinity what we have there, we don't know. So we don't have to worry about this. So leave it. Okay, so just find out first 2 to 3 terms and just guess that what will get the nth term. Okay, so here we can see our terms are look like a first term to the power 1, second term to the power 2, third term to the power 3. So after looking this term, it feels like that this is like some kind of a progression. Okay, as we learn in a geometric progression, that we know that if the ratio of these terms, if it will remain same everywhere. Okay, so the ratio of a first term and second term, which is alpha by 10, second term and third term, which is again alpha by 10, so all ratio of every term which remain here same, and secondly beta by 10, which is the ratio of every term, and it will remain same everywhere. Okay, so I got the ratio is also same for every term, So that time we can apply geometric progression for finding the sum of nth term. Okay, so we have to simplify, means we have to find the sum of nth term here. Okay, so we have to find out the sum here as well as here. Okay, so here we can see that first term alpha by 10, a which is equal to alpha by 10 is here. The common ratio between these two terms we written as r as a alpha by 10. Okay, and when we have such a geometric progression, okay, geometric progression, then we write their sum as a first term. First term means alpha by 10. Okay, first term alpha by 10 upon 1 minus common difference. Okay, common difference are as a alpha by 10. Okay, this one I did it for only alpha by 10, so do it for beta by 10. Okay, so first term beta by 10 upon minus it is there 1 minus common difference, so beta by 10. Okay, so I hope you all have understood how I applied geometric progression for these two series. Okay, so it is easier to apply, nothing is difficult there, so I applied these things over here. Okay, so it is very easy that if you are familiar with the progression chapter. Okay, so APGP is useful here. So 1 by root 5 as it is. So sum of nth term alpha by 10 upon 1 minus alpha by 10 minus beta by 10 upon 1 minus beta by 10. So just go for the cross multiplication and multiply denominator over here as I did. Okay, so it is easier that you can do it by your own. So just the calculation part. So multiply these two bracket downside, will get the 1 minus beta by 10 minus alpha by 10 and this alpha beta by 100. Okay, and again multiply this over numerator all the terms, separate the terms, so you can cancel here some terms. You will be left here with the alpha minus beta by 10, 1 by root 5 as it is, 1 minus, take negative sign common here, beta plus alpha by 10 plus alpha beta by 10. Okay, now here we have to substitute beta plus alpha plus beta value and alpha into beta value. Okay, so as we found earlier. Okay, so after substituting these values, we'll get the alpha multiplied by beta is a negative 1 is there. Okay, and beta plus alpha is a 1 is there. Alpha minus beta root 5 is there. So substitute all the values. After substituting, you can cancel root 5 with the root 5. Okay, so we will get the 1 by 10 upon 1 minus 1 by 10 minus 1 by 100. Okay, so 1 by 10 upon 1 minus L1 by 100. Go for the calculation, you will get the last step as a 10 by 89. Okay, easy calculations are these. Okay, I hope you all have understood this first option. So in our first option, it says that the summation for an upon 10 raised to n is 10 by 89. Okay, so we got the exact same option. So our option number A, which is a true. Now let's move for the option number second. Number B, we have to show Bn which is equal to alpha raised to n plus beta raised to n, and for all n greater equal 1. Okay, so by using our given data, try to figure it out. How can we get this term? Okay, so Bn we have given an plus 1 and an minus 1. Okay, so by using this term, try to reduce this term into alpha raised to n plus beta raised to n. Okay, so an plus 1 and an minus 1 we have given the value for Bn. Okay, find out an plus 1 and an minus 1 by using an. So we have an alpha raised to n minus beta raised to n upon alpha minus beta. Okay, so if an is alpha raised to n minus beta raised to n upon alpha minus n. Okay, alpha minus beta. So an plus 1 can be written as alpha raised to n plus 1 minus beta raised to n plus 1 upon alpha minus beta, and similarly an minus 1 alpha raised to n minus 1 minus beta raised to n minus 1 upon alpha minus beta. Okay, substitute these two values over here, you will get this step. Go for the calculation. So you alpha minus beta, same here denominator, take it once, add their numerators. Okay, you will get this term. Okay, so here try to take alpha raised to n plus 1 common, something beta raised to n plus 1. Go for the calculation, try to find out the next step, anything whatever you will get. Okay, in such a condition you have to go for the calculation, how your mind works, that way follow the calculations. Okay, because we cannot say that this is the second term, you will get the some another term, but you will land on same answer. Okay, so here so what I have done, alpha raised to n plus 1 I written as alpha raised to n plus 2 minus 1 as alpha raised to n plus 1. So, and alpha raised to n minus 1 taken together, because alpha raised to n minus 1 possible to take outside. So similarly done it for beta raised to n minus 1. Okay, upon alpha minus beta. So take alpha raised to n minus 1 common, beta raised to n minus 1. So we'll get the alpha square plus 1 beta square plus 1 inside bracket upon alpha minus beta. Okay, so we know the value for alpha minus beta, but now we want the value for alpha square plus 1. Okay, and by using alpha square minus alpha minus 1, try to guess the value for alpha square plus 1. Okay, so what we'll get the value for alpha square is a alpha plus 1. So alpha plus 1 plus 1 alpha plus 2. Okay, so alpha raised to n minus 1 alpha plus 2 plus beta raised to n minus 1 beta square beta plus 1. So beta plus 1 plus 1, which is a beta plus 2. Okay, So, and we have 1 by root 5 multiple, okay, for this. Because of that, alpha minus beta, which is equal to root 5. So 1 by root 5 I taken common out here, okay. So go for the further calculation. So 1 by root 5 as it is, alpha raised to n minus 1 as it is. Put the value for alpha. Alpha is having root 1 plus root 5 by 2 plus root 2 as it is. Beta raised to n minus 1, negative sign as it is. Beta is value 1 minus root 5 by 2 and plus 2 as it is, okay. So alter that negative sign, take negative sign out, make it positive. You will get the further steps here, okay. So 5 plus root 5 by 2, 5 minus root 5 by 2. So root 5, take it out from here. 5 can be written as root 5 into root 5 means 5. And root 5 take common from here. So similarly do it here. So negative sign out here, positive, okay. So these are easy calculation. Root 5 out here, cancel these ones, okay. So we'll get the alpha raised to n minus 1. So root 5 plus 1 by 2, beta raised to n minus 1 as it is, 1 minus root 5 by 2, okay. Positive it is here because negative sign here, so I taken negative sign outside, so it gets positive, okay. So root 5 by root 5, it is value 1, okay. Alpha raised to n minus 1 as it is. Now here we can see it seems like that this is the value for alpha. So alpha here, beta raised to n minus 1, and this is the value for beta, okay. Alpha raised to n minus 1 into alpha raised to 1. So when base is same, we add their power, okay. So alpha raised to n minus 1 plus 1, so it will be alpha raised to n only. Beta raised to n minus 1 plus 1, it will be only beta raised to n. So this is the only required option number second given, that beta bn, which is equal to alpha raised to n plus beta raised to n, okay. So our option number B is correct, okay. Now let's move for option number C. Now here in our option C, we have to find out the summation of a1, a2, an, which is equal to n plus 1 minus 1, okay, n plus 2 minus 1 for all n greater equal to 1, okay. So we know that an can be written alpha raised to n minus beta raised to 1 upon alpha minus beta, okay. So if a1 want, then replace n by 1. So alpha raised to 1 minus beta raised to 1 upon alpha minus beta. A2 replace n by 2, a3 replace by n by 3, okay. So you will get this term. So we know that alpha minus beta is common everywhere and which is having a root 5 value. So put the value of root 5 and take it out here, okay. So I done it here, 1 by root 5 out here. So alpha minus beta plus alpha square minus beta square plus alpha cube minus beta cube, remaining terms here, okay. Take the terms of alpha together, beta together, okay. So here we can see 1 by root outside, and here again we see that here, okay, we got the some kind of a series here, okay. That series represent that the addition for alpha is here n times, okay, power n, that power as n times. So this is a geometric progression. So this is also geometric progression. So apply the nth term of a geometric progression. Sum of nth term of geometric progression is Sn is equal to a into 1 minus r raised to n upon 1 minus r, okay, and r smaller than 1. And similarly a Sn, when r bigger than 1, we write a into r raised to n minus 1 upon r minus 1. This is the geometric progression we have to apply over here. So after applying this geometric progression, as we know that alpha beta smaller than 1, okay. So if you don't know, you may go for calculation 1 plus root 5 by 2 and 1 minus root 5 by 2. Find out their division, addition, you will get their value smaller than 1, okay. So if alpha beta is smaller than 1, so we have to apply this result, okay, this one. So apply this result over here, okay. So here a as a first term, r as a common difference. So first term is alpha, common difference is alpha. First term beta, common difference beta, okay. So apply this term alpha, common difference alpha, first term beta, common difference beta, okay. So go for the calculation 1 minus alpha, 1 minus beta, okay. Make their denominator same. So I multiplied by 1 minus alpha, 1 minus beta here as well as here. Here I did same. Go for the further calculation, just the easy part of calculation that I am skipping here. This is the multiplication under bracket. You will get this term. So alpha beta put minus 1, beta plus alpha put 1, alpha beta minus 1, alpha beta minus 1, okay. And the left whole term is alpha plus 1, 1 minus alpha raised to n minus beta minus 1, 1 minus beta raised to n upon 1 minus 1 minus 1, okay. So 1 minus 1 minus 1, okay. So these are the value, okay. So now we want the value for alpha square and other term, okay. So alpha square can be written as alpha plus 1 by using our two equations. Beta square can be written as beta plus 1, okay. Now put these values over here. So I want the alpha plus 1. I got the alpha plus 1 as alpha square, 1 minus alpha raised to n as it is. Again further beta plus 1, okay. Beta plus 1 can be written as beta square, 1 minus beta raised to n upon minus 1, okay. So this is the next term here. Let's move for further term. We will get the next term as alpha square minus alpha raised to n plus 2 minus beta square plus beta raised to n plus 2, okay, upon minus 1. So 1 by root 5 as it is. Just go for the expanding these terms, okay. Alpha square minus beta square can be, how can we write a square minus b square, a minus b, a plus b. Similar way, alpha square minus beta square minus alpha raised to n plus 2 plus beta raised to n plus 2, take negative sign common, you will get the under bracket this term. So minus 1 here, that is the value for alpha minus beta. Okay, so alpha plus beta. So here go for the further value, just these values are there. Okay, alpha minus beta is a minus, alpha plus beta is a minus 1, alpha minus beta as it is. Okay, no, this is negative sign I taken 1 here. Okay, negative 1 here, alpha minus beta, alpha plus beta, root 5 inside bracket, minus alpha raised to n plus 2 minus beta raised to n plus 2, root 5 here. Okay, and root 5 is the value for alpha minus beta. Revert back to the value for root 5 as alpha minus beta, you will get this step. Okay, so minus 1, keep as it is, alpha minus beta get cancelled, alpha plus beta is 1, so we left here only with the negative 1 value, and alpha raised to n plus 2 minus beta raised to n plus 2 upon alpha minus beta. So this is the value for a n plus 2 by using a n, which is equal to alpha raised to n plus beta raised to n upon alpha plus beta, alpha minus beta. Okay, so this is the value I generated by using a n. Okay, so option number C, which is a true over here. Now let's move for the option number D. Question is quite lengthy, so I'm taking little faster. So D, n is equal to 1 to infinity, bn upon 10 raised to n, 8 by 89 we have to show. This option exact same as option number first. If you understand option first properly, then you can solve option number D very easily. Okay, so we know that by using option B, we found value for bn. Okay, the value of bn we have to substitute over here. So bn is equal to alpha raised to n minus beta plus beta raised to n. Okay, so substitute these values over here. So alpha raised to n plus beta raised to n. So take n common, so we'll get the summation of n is equal to 1 to infinity alpha minus beta raised to n plus summation n is equal to infinity beta upon 10 raised to n. Okay, so this is the value I generated by using this. Okay, which is equal to 8 by 89 we have to show. Okay, so by using geometric progression, we write first upon 1 minus common difference. Similarly, first term upon 1 minus common difference. Go for the cross multiplication. You will get the alpha upon 10 minus alpha plus beta upon 10 minus beta. So further calculation, you will get the cross multiplication, again multiplication of denominator. So you will get the next term 10 into alpha plus beta minus 2 times alpha beta upon 100 minus 10 into alpha plus beta plus alpha beta. Okay, multiple to the value alpha plus beta. Okay, over here. So you will get the next term 10 plus 2 into 100 minus 10 minus 1, which is equal to 12 by 89. Okay, but in our option D, we say they given 8 by 89 is the required answer. Okay, so this is not true. Option number D, which is a wrong over here. Okay, so I hope you all have understood my 4 of the option, which is completely based on the factors and quadratic equation. I use some of the concept from progression also. So even after, if you found anything difficult, any step is confusing, let me know in comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.